Your first question on your review has an exponent outside of the parentheses, so we would multiply that exponent to all of the exponents inside. It would become 3 to the 4th times x to the negative 5 times 4 is negative 20, and y to the 12th. On your perfects chart, you would do 3 to the 4th and get 81. X to the negative 20th would move to the bottom and be x to the 20th on the bottom, and y to the 12th would stay on the top. Now, to enter this in EdSite, I would start with your fraction button. On the top, you can type in 81. You can either use this Y button, or you can just type Y in on your keyboard, and then the exponent button to raise it to the 12th. Then move your cursor down to the bottom, and we want x raised to the 20th. This one looks a little bit confusing, but it just means x to the 5th over 1 times 1 over x to the 12th. So really this is the same as x to the 5th over x to the 12th. Division, so we would subtract our exponents. That would be x to the negative 7th. Negative exponents have to move, so this is going to become 1 over x to the 7th. So fraction button, 1 over x raised to the 7th. We have a little bit of simplifying to do here. On the top, 18 times 5 is 90. X times x to the 5th would be x to the 6th. So I'm looking in the numerators, and I am finding the x's. It's x to the 1st and x to the 5th. That would make x to the 6th. The y's, we've got y to the 3rd and then y to the negative 4th. 3 plus negative 4 is negative 1. On the bottom, 5 times 9 is 45. X times x squared would be x to the 3rd. Y to the 4th times y to the negative 5th. We'd add 4 plus negative 5 to get negative 1. Then we start simplifying. First of all, y to the negative 1 and y to the negative 1 are going to cancel each other out. 90 divided by 45 is 2. X to the 6th over x to the 3rd, we'd subtract those exponents and get x to the 3rd. Or you could think of it as these 3 cancel out 3 of the 6, leaving you with 3 left over. So our final answer here is 2, I don't want that, x raised to the 3rd. Three to the 2/3 raised to the 3/4. You'd multiply those exponents together. So we need to do 2/3 times 3/4. So do this in your calculator. You can multiply this and get 6/12 and then simplify that to 1/2. So you can do this using your actual brain to do the fraction multiplication, or you can use your calculator. 2 ABC button 3 times 3 ABC button 4, and then simplify that fraction. It is 1/2. So this is 3 raised to the 1/2. So in here we would type in 3 raised to the fraction 1 over 2. X to the 1/2 times x to the 2/3. When you're multiplying, you add your exponents. So we need to do 1/2 plus 2/3. You could get common denominators if you wanted to. I prefer to just stick this into my calculator and get the fraction 7/6. So x to the 7/6. We would type in x raised to the fraction 7 over 6. This is the first one that isn't super straightforward. You cannot combine the 2's because the index is not the same. You have to remember that the square root of 2 is the same as 2 raised to the 1/2. The 4th root of 2 is the same as 2 raised to the 1/4. Now the bases are the same and we're multiplying, so we're going to add those exponents together. 1/2 plus 1/4 is 3/4. So our answer here is 2 to the 3/4. But if you type it in that way, it is going to be incorrect. It would help if I could write the word correctly. This problem started in radical form, so the answer needs to remain in radical form. So we need to change this back into a radical. This is the fourth root of 2. Remember that the bottom is always the index. The top is going to be the exponent. So the fourth root of 2 raised to the third. To do this in here, it's nice to put this on your paper and then try to put it into the computer. If you just try to put this straight into the computer, it can be a little bit confusing. So I want parentheses. In there, I want the fourth root. I want this nth root thing. And then we type in 4 there. We want the fourth root of 2. And then outside of the parentheses, we raise this to the third. So this is the fourth root of 2 raised to the third. The third root of 48 plus 4 times the third root of 6. We can't currently add these because the radicands do not match. 8 and 6 are not the same. Oops, that's 48. 48 and 6 are not the same. We can, however, split this up. You want to split it up into the third root of something on your perfects chart. So look in the thirds column. Numbers less than 48, I see 27. So I try 48 divided by 27, and I get a decimal. 47 divided by 8 is 6. Now, notice this actually gives you a hint about what this one is going to be. All right, the third root of 8, I don't know why I keep saying fourth. The third root of 8 is 2. So this term becomes 2 times the third root of 6. We still have plus 4 times the third root of 6. Because we have 2 times the third root of 6 and 4 times the third root of 6, those are the same, we would add the numbers together. 6 times the third root of 6. To type that in here, 6. Then you type this nth root. You want the third root of 6. X over the third root of y to the 8th. Well, the x is fine. But when I think about the third root of y to the 8th, how many groups of 3 are there in 8? 1, 2, 3, 4, 5, 6, 7, 8. There's 2 full groups of 3, so that would be y squared. And then these 2 would still be stuck under a radical. So you still have y squared under the radical. Now this is bad. We can't have a radical on the bottom. So we need to multiply by the third root of however many y's it would take to complete the group of 3. So right now we have 2. We need 1 more to complete that group of 3. When we complete that group of 3, this thing is now the third root of y to the third. So you could rewrite this as the third root of y to the third if you wanted to, which is simply a y. So this whole thing cancels and becomes just a plain y. So on the bottom, we have y squared and another y. So on the bottom, we have y to the third. On the top, we have x times the third root of y. I would start with your fraction button. X times the third root of y over y raised to the third. You would start this problem by splitting it up into all the different pieces. Then, for the third root of 24, you'd use your perfects chart. Look in the thirds column at the numbers smaller than 24. There's only 8, so this is the third root of 8. 8 times 3 is 24. The third root of 8 is 2. So this piece simplifies into 2 times the third root of 3. Then we go to x's. The third root of x to the 12th. How many groups of 3 are there in 12? There are 4 full groups of 3, so this becomes x to the 4th. 12 divided by 3 is 4. For the y's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 3 full groups of 3 with 1 left over. That 1 that's left over is still stuck under the radical. For the z's, 1, 2, 3, 4, 5, 6, 7, 8. There are 2 full groups of 3, and there are 2 left over under the radical. These 2 are leftovers still under the radical. You can also think of it as 8 divided by 3 is 2, remainder 2. And I just noticed that I wrote y instead of z. That would be a problem. Now for your final answer, numbers and letters that are not under a radical, numbers first, then letters in alphabetical order that are not stuck under a radical. Then one radical symbol, numbers, letters in alphabetical order. So you're still going to move from left to right, first getting all of the things that aren't under the radical, and then one radical symbol, and then catch all of the things that are still stuck under the radical. When we type that in here, we have 2x to the 4th. Don't forget to get your cursor out of the exponent before you type in your y raised to the 3rd. Get out of the exponent. There's no z on here, so you will have to use your keyboard to do z. Z raised to the 2nd. Get out of your exponent. An nth root, make sure you type in that that is a 3rd root of 3y. And again, there's no z on this thing, so you do have to type in z and then raise that to the 2nd. There is our final answer. Again, it's helpful to have that written down on your paper before you try to transpose that into the computer. Which expression is the simplified form? So it's kind of hard to see, but there are parentheses around this with a 2 on the outside, with an exponent of 2. So this is going to be 6 squared x to the 10th y to the negative 4th over 9 squared x to the negative 4th y to the 6th. Now this one is multiple choice, so you can use a few tricks to help you get your answer a little bit faster. 6 squared is 36, 9 squared is 81. If you simplify the fraction 36 over 81, you get the fraction 4/9. Look at your answer choices. Only one of them has a 4 on top and a 9 on the bottom. You could then check if you wanted to. These 4 x's would move to the top and you'd have x to the 14th on the top. These 4 y's would move to the bottom and you would have y to the 10th on the bottom. So your answer there is 4x to the 14th over 9y to the 10th. Simplify negative 64 raised to the 4/3. The easiest way to do this is change it into radical form. Remember, the bottom number is the index, the top number is the exponent. Using your perfects chart, the 3rd root of 64, you can do the 3rd root of negative 64. The 3rd root of positive 64 is 4, so the 3rd root of negative 64 is negative 4. Then negative 4 raised to the 4th. Well, positive 4 to the 4th is 256. Negative 4 to the 4, there's an even number of negatives, it would still be positive 256. Now, if you try to type in negative 4 raised to the 4th in your calculator will tell you negative 256 because your calculator is actually doing this part first and then sticking the negative on the front. If you want to do this in your calculator, make sure you enter it this way with the parentheses around the negative. Okay, there are still 3 problems left on the review, and I only have like 2 minutes left on my recording, and I'm not going to be able to do justice to those 3 problems in only 2 minutes. It's not going to be fair to you. So I'm going to stop the recording here and record a second video that goes through the last 3 questions. So make sure that you watch the second video as well.